Hello my friends, in this video I'll share how to set up an OrangePi 5, the Pro model in my case, to participate in the new Neutronex project, resolving tasks for the Einstein at Home project, aiming to discover new neutron stars lurking in the outer space. The OrangePi 5s are powerful rock-chip mini-computers, the ARM64 devices being rewarded 5 times more than the AMD 64 ones as Neutronex aims for low power consumption computation power, but they're a bit overpriced, so, in my opinion, the best gear to use for this project is what we already own. Okay, disclaimer out of the way, I acquired an OrangePi 5 Pro, case and cooling for about €135. After assembling it, looking at and testing various images to flash the SD card, I chose the Debian Bookworm server linked from the OrangePi website. By the way, the OrangePi has a M.2 slot, supporting NVMe SSDs or SATA SSDs, but for the scope of this video, a micro SD is enough. But not any SD card, choose a high-endurance one. I'll leave links to everything in the description of this video. As OS, I chose the Debian Bookworm 106, the server version, linked on the OrangePi website. I already have it downloaded, and I can assure you, there's no virus attached. Navigate to the folder where the image was downloaded and extract it, if necessary. I used 2 software programs to flash the image, Rufus, which needs the image extracted, and Balena Etcher, which can flash archived images as well. They will both be linked in the description. I'm showing examples how to use them both, but using Balena Etcher to complete the flashing process. Connect the micro SD card to your PC. Hopefully, you have a way to do that, an incorporated card reader writer, or an external USB variant. Select the downloaded image. I have more distinct ones on my drive because I've tested various images until I found one working without complications. Preparing both programs for flashing the SD card, but, as I've specified, I'll use Balena Etcher.
Cracking codes while y'all crack jokes.
The process is fast-forwarded, it might take up to 10 minutes. When it finally finishes, close the flashing program, remove the SD card and insert it into the OrangePi. There are 3 possibilities to continue with the setup. Use a monitor and a LAN, or Ethernet cable. In this case, forward the video to the image setup and Docker installation part. Use a monitor, but no LAN cable, in which case, continue watching to see how to connect to the Wi-Fi access point. Or, don't use a monitor, but use a LAN cable, in which case, we continue with the headless setup and SSH access. If you don't have a LAN cable, but a monitor, or a TV, to connect to, and a keyboard, the Debian OS has a built-in Wi-Fi user interface, to use to connect to your Wi-Fi access point. The following video sequence will show you how, but please excuse my amateur filming skills. The IP won't appear on your display, it appears on mine because it's already connected. The command line will be in the description as well alongside a full written guide engulfing all the setup process. Select the access point from the list, insert its password. After it successfully connects, use the escape key to exit this menu. If you don't have a monitor, or the needed cable, for visual access, connect the OrangePi to your internet router using a LAN cable and power it on. The next step is to find the device's IP, to access it remotely, as Secure Shell Access, or SSH, is pre-activated on this OS. To find the IP address, we can use third-party programs like Advanced IP Scanner or Angry IP Scanner, or log into the internet router and check the Connected Devices tab. I choose the router way. Usually, the login credentials are shared on the back of the router, and of course, every router type interface is different, but the OrangePi will appear as itself by the connected wired devices. Local IP found, it's time to connect to the OrangePi. If, by any chance, you'll see an IPv6, or Internet Protocol version 6, instead of an IPv4, like in the example of my Raspberry Pi here, and no IPv4 shown, it doesn't matter. Any IP will suffice for the next step. Open a command prompt and type this command line. If you only found an IPv6, place that at the end, after the @ sign. In my case, it's a IPv4, the generic password for SSH access is OrangePi. We start by upgrading our system. The generic password, again, is orangepi.
Idle power's wasted, now we weaponize that. Neutronex on Solana, science in the trap. From neutron stars to the bag in my hand. This is cosmic crypto, y'all don't understand. We breaking limits.
Interact when necessary, Y and enter.
But we cashing the gains. While y'all mind memes, I mind the unknown. Turning faint signals into money I own. Lego, Mercot.
The next step is to install Docker. I'm recording it at a later date and that's why I have to insert the password again. It shouldn't be the case for your installation. I'm pasting the command lines from the official documentation, which will be linked in the guide posted in the description of this video.
Y'all flex fake hype, pump and dump trash. We flex pure science, concrete cash. This ain't speculation, this is proof and code.
The command line to pull and install Docker, finally.
Lightning fast in the fight. Rewards hit wallets every single night. While they chase vapor, we crack in the skies, pull SARS, whisper secrets, and we
Removing unnecessary packages.
watch when you can weaponize. Why mine dust when you can digitize skies? Neutronex soldier, the mission is
We can see that the Docker service is disabled, meaning it's not running, but besides starting it, we have to enable it so the service starts whenever the orangepi is rebooted. Use these two command lines for the proper setup. In my case, I learned the hard way. Every time I was rebooting the OPi, my containers were disabled until I was interacting with them.
mind is real, building the specs. The future is cosmic, the name's Neutronex.
Docker is installed and running. We can now set up Neutronex, Watchtower for auto updates and Tailscale for remote SSH access.
Idle power's wasted. Now we weaponize that.
To install Neutronex, copy and paste the command line from my guide from the description of this video, replace the wallet address and the Einstein at home account key with your own credentials.
We breaking the chains. Einstein at home, but we cashing the gains. While y'all mind memes, I mind the unknown. Turning faint signals into money I own. Lego Mercot to Receibo's ghost. Gamma ray fire where I brag the most. Data don't sleep, so my rig never rest. Science on chain, put the skeptics to test. Root burn at, light it up, let it bang. Crunch the stars till the universe sang. Idle to vital, turn heat into checks. Cosmos to crypto, respect Neutronex. Y'all flex fake hype, pump and dump trash. We flex pure science, concrete cash. This ain't speculation, this is proof and code. Every idle core is a block we load. Solana, the chain, lightning fast in the fight. Rewards hit wallets every single night. While they chase vapor, we crack in the skies. Pulsars whisper secrets, and we monetize. Why waste watts when you can't weaponize? Why mine dust when you can digitize?
Looks like Neutronex is working as intended when checking the logs. To optimize the Neutronex, mining, or better said, to optimize Einstein at home task completion, we have to edit the override file. I'll explain a bit what the options mean. Navigate using the arrows. PCT means percentage.
We don't beg moons, we scan for the truth.
It determines when the device is considered in use, how much time after the last mouse or keyboard use to wait until it starts computing again. It allows some devices to enter low power mode after mouse or keyboard last use, but I don't know to which type of computers it refers to. Setting it to 0 looks like the best setting if this option applies to our orangepi devices. It suspends the computation for Neutronex if the CPU is in use by other programs more than the set number as a percentage. Set it to 1 for the suspended computations, or tasks, to be stored in memory and resume from the last checkpoint, no work being lost. The period to compute for one task before jumping to the next, most of the time 60 minutes is enough. Set it higher if you see unfinished tasks in the Einstein at home dashboard. Maximum cores to be used for solving tasks. The percentage has to be exact. In the case of the OrangePi5, there are 2 CPUs, each 4 cores. 87.5 means using 7 cores. I leave 1 core to be used by the system and other programs. Which cores are selected for the tasks, we can't set it up. I would have preferred a setting to choose the more powerful ones first. The time the selected CPU cores to work on tasks. If it's set at 90%, it works 9 seconds out of 10. If it's set at 75%, it works 3 seconds out of 4. In my case, 100% working time. But consider having a good cooling system in place. I'll leave links to the parts I've purchased in the description as well. The maximum and minimum space used for the project. Make sure the last line, the percentage, is not set less than the maximum set in the first one. How often, in seconds, tasks save their state to the disk, so they can be resumed from that point in case of interruption. virtual memory, or page file, or swap file, it shouldn't be higher than 3 times the total random access memory, or RAM. It might speed up the task completion, but it'll occupy that space on the disk. If you don't have a big enough disk, leave it 0, it won't make such a big difference. The total RAM to be used when the device is at use or not at use. Store at least that amount of days of work locally. It can be used as decimals like 0.5 days, and the additional work in days to be stored in case the first amount finishes earlier. These are the settings I consider important for optimizing our devices according to our needs. I'll leave a link to a full explanation regarding every setting in part in the description, as always. I'm stopping the Neutronex container to continue with the setup. In any case, after the override file is modified, the container has to be restarted. You can grab the command line from the Neutronex website. It needs super user permissions, or check my description and copy-paste it from there.
Neutronex grind, we expand in the land. Pulsar spin, we stacking these wins. Crunching those signals while cash rolls in. Neutronex bridge from compute to earn.
The next command line, which you'll find below as well, is for the Tailscale container. This one allows us to remote connect to our OrangePi from other networks and locations, always being connected to it if necessary. For Tailscale to work, you need an account created, and a key. To create a key, go to Settings in your Tailscale admin console and hit the Generate button. Make the key reusable if you want to use it with more devices, and ephemeral to be auto-removed anywhere from 30 minutes to 48 hours after the last activity. Store your keys locally as they won't be stored on your Tailscale admin console. Insert the key in the command line and give your device a name, which is not a Raspberry Pi for sure. My bad. I pasted the command line I used for my Raspberry Pi setup, the command line I used in the previous video. It should appear in your Machines tab, but, in order to be able to connect to the OrangePi remotely, the Tailscale app has to run on your computer or phone, on the device you want to use to connect to the OrangePi with. Right-click, Network Devices, click on the desired device and its remote IP will be copied to the clipboard. Open a terminal to test it. Tailscale is working. We have our 3 necessary containers installed. Next, start the Neutronex container and you're good to go. After a task is completed, or solved, or validated, it appears in the Neutronex console. In order to earn the Neutronex token, we need a license. Thanks for watching.
Why waste watts when you can't weaponize? Why mine dust when you can digitize skies?